This is the fifth video of the section, performing a multiple regression analysis. In the previous video, we measured the performance of the regression model. In this video, we demonstrate how to predict house rental prices with multiple variables. Multiple regression analysis can be regarded as an extension of simple linear regression. You can use multiple regression analysis to predict the value of a dependent variable based on multiple independent variables. A multiple regression is a regression model with two or more independent variables. Unlike simple linear regression, which is modeled with a straight line, multiple regression analysis is modeled as a function with multiple independent variables. The model has the form response terms 1 plus terms 2 plus term Sn, where n is the number of independent variables. You need to have downloaded the house rental data into a variable house beforehand. First, you need to fit square foot, floor, total floor, bedroom, living room, and bathroom into a linear regression model. Then obtain the summary of the fitted model using summary function. It's executed. All the data is stored in it as shown here. Now you can predict the possible house rental price with the fitted model. And this is the output. Diagnostics are methods to evaluate the assumptions of the regression, which can be used to determine whether a fitted model adequately represents the data. In the following example, we introduce how to diagnose a regression model through the use of a diagnostic plot. Plot the diagnostic plot of a regression model. Let's use the par function for details. Here you can see the output. The plot function generates four diagnostic plots of a regression model. The upper left plot shows residuals versus fitted values. Within the plot, residuals represent the vertical distance from a point to the regression line. If all points fall exactly on the regression line, all residuals will fall exactly on the gray dotted line. The red line within the plot is a smooth curve in regard to residuals, and if all dots fall exactly on the regression line, the position of the red line should exactly match the gray dotted line. The upper right plot shows the normal QQ plot of residuals. The plot verifies the assumption that residuals are normally distributed. Thus, if the residuals are normally distributed, they should lie exactly on the gray dotted line. The scale location plot in the bottom left measures the square root of the standardized residuals against fitted value. Therefore, if all dots lie on the regression line, the value of y should be close to 0. As it's assumed that the variance of residuals does not change the distribution substantially, if the assumption is correct, the red line should be relatively flat. The bottom right plot shows a standardized residuals versus leverage. Leverage is a measurement of how each single data point influences the regression. It's a measurement of distance from centroid of regression and level of isolation, measured whether it has neighbors. Also, you can find the contour of Cook's distance, which is affected by high leverage and large residuals. One can use this to measure how regression would change if a single point is deleted. The red line is smoothed in regard to standardized residuals. For a perfect fit regression, the red line should be close to the dashed line with no points over 0.5 in Cook's distance. In this video, we've performed a multiple regression analysis. Amazing! In the next video, we'll select the best fitted regression model with stepwise regression.